So welcome Level 2 NCEA physicists, looking at our 2.1, our nonlinear relationship internal. And the first thing we have to do is plan our experiment. So three components of that are the aim. Okay, so the aim is essentially the purpose of the experiment. It should be about 1 or 2 sentences. Then you'll do a preliminary experiment to find the range of your independent variable, any potential limitations that are going to be happening in your experiments, work out control variables, and also work out how to measure your independent and dependent variables. Then we have the hypothesis. So the hypothesis will be a prediction that will be based on a scientific theory. Okay, so usually you're going to be given an equation and the physics that's based around that equation. So you ought to write a little hypothesis predicting what's going to happen, which is usually 1 to 2 centimeters. Sentences. Okay, so the method is an important part of your internal. So basically it describes how the equipment is set up, describes how the dependent variable is going to be measured, describes how the independent variable is changed, and describes how other variables are controlled, and also will include a label diagram. So there'll be, in your assessment, there will be a basic method which you may have to build upon depending on the results of your preliminary experiment that you'll do in pairs for the first lesson. Then we have the independent variable. The independent variable is the variable that you're going to change, okay, and you're going to have to state it, describe how it's changed, identify and justify the range you've chosen from your preliminary experiment, test at least 5 values, but I will expect you to do at least 7 different values. Describe how you've increased the accuracy of the equipment, therefore the accuracy of the independent variable, and describe any challenges that you experienced and how you overcame those potential challenges. Then we have the dependent variable. Again, you're going to have to state the dependent variable. I recommend maybe doing this in a table. Describe how you've taken the measurements in the dependent variable, because the dependent variable is the variable that you're going to be measuring. Take at least 3 values for each independent variable value. Okay, so you'll have 3 dependent values for every independent variable. I expect, though, that there will be more than that. There will be 5, and I'll go through reasons why increasing the number of values that you take is advantageous. Describe how the accuracy has been increased, so that's a kind of a hint to that, and describe any challenges that you had in reading the dependent variable and how you overcame those potential challenges. Then we have the control variable. The control variable, you have to state the variables that would affect the experiment quite significantly, describe how you controlled them, and explain the effect of the experiment if not controlled. So, for example, the wind, for example, if you're doing a pendulum experiment, and how you controlled that, closing the door. There's a summary there of the different types of variables for you to pause and watch at your own leisure. So in terms of key terms for this particular internal, random error, which is basically above or below the true value, usually due to limitations in the equipment. Then you have systematic error, which is in one direction usually, and usually due to the error in instrument or method. We have precision and accuracy, which are usually misused in general language, but in physics, precision is a measure of how certain you are on that value, and accuracy is how close the value is to the accepted value. So what we're aiming for is high precision, the values are close together, and high accuracy, they're close to the value that we actually expect from theory. And then we have systematic errors. Okay, so in systematic errors, there they are, there's a couple of examples there. 0 errors and calibration errors. They also give you an example of how to correct them, and that's something you're going to have to do in your discussion and conclusion, which we will discuss later. Error, and that's going to be reduced by doing at least 3 trials for each value and averaging, giving a range of at least 5, okay, to determine the mathematical relationship. And multiple measurements are also very useful. Okay, so for example, doing a pendulum experiment, taking 10 movements of the period and then dividing by 10, and also allowing you to double check the results with your partner in that first lesson to make sure you're not making calculation errors.